This is lesson 34, number 28, and this question is asking us about this little pyramid here. It says the base of a regular pyramid is a regular hexagon whose perimeter is 36. So because the perimeter is 36, I know, I don't want to write in my book, but I know I can label these sides all as 6. Because the perimeter is 36 and there's 6 sides and it's regular, so that means that all the sides are the same length. The volume of this regular pyramid is 216 centimeters cubed. Find the surface area of the pyramid. Dimensions are in centimeters. So we're going to start out by, well, I'll probably just draw it. 3 root 3. We've got 3 root 3 right here. That's 3 root 3. Okay, I already said because the perimeter is 36, all these sides are 6. Okay, so it told me the volume. And I know that volume, it told me that the volume was 216. And I know a little formula for volume. Volume of a pyramid is 1/3 times base area times height. Now, I have 216 as the volume. The base area I can get, this is the bottom of the pyramid, if you remember the picture in the book. That's the bottom of the pyramid, that's the base, and that's showing what the pyramid looks like. So all I have to do is chop this thing up into triangles, and that'll give me my base area. So I can see I could draw 6 triangles. So the area of a triangle, the little formula for area of a triangle is 1/2 times base times height. But the base is 6, and the height is 3 root 3. Okay, now 1/2 of 6 is 3. So now I've got 3 times 3 root 3. Well, that gives me 9 root 3. Now what was that? That was one triangle. I'll write a triangle on it. That's what one of these triangles is. But for me to get the whole base area, I need to multiply it by 6. Okay, so I'm going to multiply it by 6. 6 times 9 is 54. So, got 54 root 3. I'm going to write base area because this is a long problem and I might need to look it back up again. Okay, the base area is 54.3. I can also write that into my formula. 216 equals 1/3 times 54 root 3 times the height. Well, I don't know what the height is, but I know I can figure it out by just using some algebra. So I'm going to first of all say what is, hopefully I have my calculator. I think I can probably figure out what is 1/3 of 54 because, well, I think it's 18. I think 18 times 3 is 50. Should I check that? 54 divided by 3. Oops. 54 is 18. I just wanted to check, because if I mess up now, then I'll have something messed up all through the whole thing. So it's going to be 18 root 3 times height is equal to 216. Then I want to divide, I want to get h by itself. So divide by 18 root 3. That's going to give me 216. I got my calculator right here. 216 divided by 18 is equal to 12. It's 12 over root 3, but I don't like to leave it like that. I like to rationalize my denominator. So if I multiplied on the top and bottom by root 3, I'd have 12 root 3 over 3. Oh, thank you. 12 root 3 over 3. And 12 root 3 over 3, 12 divided by 3 is 4. So I'm going to get 4 root 3. That's the height of what? That's the height of the whole pyramid. So, height of pyramid. Okay, so now I have two. So I have the base area, I have the height of the pyramid. my overall goal is to find the surface area of the whole pyramid. For surface area, so maybe I have enough information now. For surface area, let me write something about surface area. It's going to be the base area plus the lateral surface area. I'll write SA for surface area. Okay, I already know the base area because I just did it. It's 54 root 3. I don't know the lateral surface area, but I see there's a picture in my book right here, and I see that the lateral surface area is made out of a bunch of triangles, and there's 6 triangles, and I think I could somehow do 1/2 times base times height on there and find out what one triangle is and multiply it by 6 or whatever. So I think I'll draw a little picture of that onto my paper so I can remember what I'm doing. I'm just drawing this as a little reminder of what I'm trying to do here. I know that the bottom of, I know that each of these sides of the base area is 6, and if only I knew this height right here, this dotted line, then I could just go 1/2 times base times that height, and I would get the area of one of the triangles. Well, I can get that height, it's kind of a slant height. I can get it using Pythagorean theorem, because you know I have this would be like along the bottom. This is 3 root 3, and that would be along the bottom, and then I'd have, I don't know if you can see that on TV, I'd have this one going up, this height going up. I know what that height is, it's that. So this would actually be a hypotenuse to a triangle that's standing up inside the middle of the figure. So I'm going to use some Pythagorean theorem. I think I'll do it down here. I'm going to go 3 root 3 squared, because that's this part. 3 root 3 squared plus this height here squared, because that's going to give me from the middle all the way up to the top. That's going to give me my height. Well, I mean, that's going to give me it's going to give me this dotted line thing that I need, so that I can get the area of these triangles on the outside of the figure. So, if I square 3, I get 9. And if I square root 3, I get 3. So that gives me 9 times 3, that's 27. And if I square 4, I get 16, and if I square root 3, I get 3, and so 16 times 3 is 48, I think. And that's c squared, and 48 plus 27, looks like that's 75, is c squared, and then I'm going to square root both sides. So c is going to be root 75. Root 75 can be written as, well, that's 25 times 3, that's going to be 5 root 3. So that's this thing. This is 5 root 3. Now I can finally find the area of the triangle. It's 1/2 times base times height. Well, 1/2 of 6 is 3. And 3 times 5 root 3 is 15 root 3. Okay, so one of these triangles is 15 root 3. But for my lateral surface area, I need to add up the 6 triangles. So I have to multiply that by 6, and 6 times 15, I should know this. 6 times 15 is 90. Root 3. That's the 6 triangles on the outside. And this is the base area. And then if I add the 90 and the 54, then I get 144. So this is 144 root 3 centimeter. They were in centimeters. Centimeters cubed. That's the surface area. Ta-da! That was lesson 34, number 28.